Hey there, welcome back. Today I have got something exciting in store for you. We will be diving into the world of Jetpack Compose and building a classic snake game from scratch. Yes, you heard it right. A game right here in your favorite Compose framework. But hold on, this won't be your typical snake game. We are not stopping at the basics. We will be adding some spice to it by leveraging the power of the canvas in Jetpack Compose to bring our snake to life with custom graphics. Plus, we will be throwing in some sound effects to make the whole experience even more immersive. Now, if you are not familiar with Jetpack Compose, it's Google's modern UI toolkit for building native Android applications. It's based on a declarative UI pattern, which means we can describe how our UI should look based on the current state, and Compose takes care of the rest. And don't worry, if you have never worked with Compose before, I have got you covered. We will start from the basics and work our way up to building a full fledged snake game that you can proudly call your own. If you are excited about this tutorial, don't forget to hit that like button and do subscribe. Alright, without further ado, let's jump right into it. So here I have created this new project. You can also do so. So for that here you just need to go to this file new project and select this empty activity and then next. Here you can name your application. I have used snack game as the name and minimum SDK we can select 21 and we will use Kotlin DSL for Gradle build because it's a recommended one. So after doing all this, just press this finish button and your project will be created. So first thing what you need to do here, you need to go to this build.gradle file module level. So in this project, we will use this version and all these dependencies you will get with the new project. You only need to paste these two dependencies. You can copy these two from the GitHub repository. You can get the link in the description. Because we will use some images, so let's add those images also. In this resource package, here we have this drawable package. In this drawable package, I will paste some images which we will use in our project. Select this one and OK. So these are the images we will use in our project. You can get these images from the GitHub repository also. And after these images, we will add two sound effects. So for that here, let's press right click and new Android resource directory. So those sound effects we will use in this raw resource type. Press OK. So here we have one more package with the raw name. So I will paste those sound effects. You can also get these from the GitHub repository. These two for the food and this one for the game over. And next we will add some colors. So here in this UI package, we have this theme package and then this color file. So these three colors we will use in our project. And let's also use this royal blue color as our primary color. So for that here in this theme file, we have these two color schemes. So here we will use that royal blue color as our primary color and for the dark mode also. So let's close these two files. And here with the new project we get these codes. So let's just remove these code. To keep all our UI related code, we will use a separate file. So here let's create a new Kotlin file with the name snake game screen. Let's take the composable function. Our whole screen will be consisting of three elements, that scorecard and that canvas and then row of buttons. So here we will take the column layout because these elements are placed vertically above and below. So for that we have this column layout and in this we will use the fill max size modifier. This fill max size modifier will take up the whole phone's screen. So in this column, first we need to create that scorecard. For that, we will take a card, and in this card, we will use text composable. So here in this card, first we have taken this padding modifier. So this padding modifier will give 8 dp padding all around this card. And then we have used this fill max width modifier. So this card will take up the whole width of the phone's screen. And in this card, we have used this text composable to show this score. So here again, we are using this padding modifier to give 16 dp padding all around this text composable. And here we are using this styling from the material theme headline medium. So here when we press Ctrl B, we can see with the material theme we get these 15 types of styling. We can choose among these. So first let's minimize these imports and use our screen in our main activity because this is the entry point. So here we will say snake game screen. Let's run our app and see how this is looking. So here we have our scorecard. It is looking pretty good. So next, let's minimize this also. So after this scorecard, we will design our game board. So for that, let's take the canvas. So here this on draw parameter we will use in these parentheses. We use canvas to draw custom charts, a shape or any visual element that is not covered by the built-in compose component. Think of the canvas as the blank canvas on which you can draw whatever you want. And we must need to specify the size of the canvas, otherwise this canvas will not draw anything. Here we will give the size of this canvas relatively because different phones have different screen sizes. So here we will use the modifier. First one we will use this fill max width modifier. So this canvas will take the maximum width of phone's screen, whatever will be the screen width of that phone. And for the height we will use aspect ratio. Ratio will be 2 by 3. So it means we need the 2 units of width with 3 units of height. And here let's press some enters. So here in this draw scope, we get so many draw functions to create custom shapes. So here let's type this draw and we can see here we have these many functions: draw arc, circle, image, line, oval, path, points, rectangle, round rectangle. So with the help of these basic shapes, we can draw whatever we want. So first we will draw our game board with the help of this draw rectangle. But for that draw board, let's create a separate function with this draw scope. So here let's create a private function and let's name this function as draw game board. So to draw the board, we will pass some values to this function and then with those values we will draw our game board. So these values we will pass to this function. So here in this canvas, let's use this function draw game board. And here first we need to specify the cell size. For this cell size, we will take the size of this canvas. Because we are in this canvas, so we will get this size value of this canvas. So here with this size, we will take the width of this canvas and we will divide the width with x-axis grid size. We will use the x-axis grid size to 20 and y-axis grid size to 30. So this is how our cell size will be calculated. Suppose we have the screen width of 200 units and we have 20 grid size. So it means the cell size will be 10. So let's use this cell size here. And next this cell color we will use this custard. So here let's press Ctrl B. So this is the same color we pasted in our color file. And after this border cell colors, we will take the royal blue and grid width will be 20 and grid height will be 30. So with the help of these values, we will draw our game board. So here we will use two for loops. So in this loop, it will draw all the rectangles in that first column because we are looping through this grid height. And then after creating the first column, it will loop through all the grid width value and then it will create all the columns throughout the row. So here we will use this draw rectangle. So here we need to specify the color. And next we need to specify the top left offset from where it will start drawing that rectangle. So this x value will be calculated through this I value into cell size and this y value will be j into cell size. And next we need to specify the size. For the size, width and height will be same. So this is how our game board will be drawn. Now we can run our app again and see this board. So here we have our game board. But right now we can just simply see a big rectangular box because all these smaller rectangles are of same color. That's why we are not seeing that smaller boxes. So now next thing we will give color values differently. So here first let's calculate is the cell is border cell or not. So here this is how we will calculate. So if the I value is 0, so it means it is in the first row because this I value is of this grid width. And next we are checking if the J value is 0, it means it is of the first column. And next we are checking if the I value is grid width minus 1, we are subtracting 1 because index start from the 0. And in the same way we are checking for the last column. So this color value we will give with the help of if block. If the cell is border cell, then we will give the border cell color. And for the rest of the colors we will give alternate colors. So in this else if we are checking if the value is even, then we are giving this cell color, otherwise we will give the cell color with the alpha value of 0.5. Now let's run our app again. So here we have our game board as expected. Next, we will design those two buttons. So let's minimize these two things. So here after this canvas, let's use a row because those two buttons will be placed side by side. So here first I have used this row layout, and in this row layout we are using the same padding modifier and then fill max width modifier. So here in this row we have used these two buttons, and for these two buttons I have used this weight modifier. So these one weight value will make sure that these two buttons will take equal space, and in between I have used this spacer to give some space in between. So let's run our app again and see this. So we can see our two buttons are looking perfectly good. One thing we need to improve is here we can see all these three childrens are arranged in the top. Again we will arrange these childrens relatively. So here we have this vertical arrangement parameter. So we will use space around arrangement dot space around. So we can choose among these. So this space around will arrange the childrens like this. It will give some space before the first child and some space after the last child, and in between it will give equal size. So next thing we will create states. So first let's minimize this, and here let's create a new file with the name snake game state. It will be of type data class. So first of all, what is state? State is any value that can change during the usage of app. These are just simply values, but they can change during the usage of app. So in this data class, we will keep all our state at one place. So here first value we will create for the y-axis grid size. It will be of type integer and we will give 20 as the default value. And in the same way, let's use the x-axis grid size. X-axis grid size will be 20 and then y-axis grid size will be 30. Next, we will keep the direction. So for direction, we don't have any type. So we will create our own type with the help of enum class. So we will have four types of direction. So this direction value will be of type direction, and initially it will be right direction. And next we will keep the value of snake coordinates list. So again let's create a data class with the name coordinate. In this data class we will have this x coordinate and then y coordinate. So this list will be of type coordinate, and for the initial value we will keep one value of coordinate because we always need to keep the head of that snake. So for that head we will use the coordinate. So our snake will start from this coordinates, and next we will keep the food coordinates. So here what will be our initial food coordinates? So these initial food coordinates will be different every time. So we will generate some random food coordinates. So here let's create one function in this companion object with the name generate random food coordinate. So this function will give us this coordinate as the return, So here how we will generate this, we will use the random class from this Kotlin library. And here let's use this next int function. So we will take the value in between 1 until 19. And for the y value, we will take in this range. So here why we are not taking the value from the 0 since that index starts from 0. This is because in the first column we will have the border of that board. So we don't want that food coordinates to be in that border cell. And for the same reason we are taking the 19 and 29. So here let's use this generate random food coordinates function. So every time it will give us the random coordinate value of this food. And next we will keep the value of this is game over. Initially it will be false. And last we will save the value of this game state. Again let's create a enum class. So here our game state will be of three types. So it will be idle or started or paused. So initially we will say the idle as the game state. So now let's go back to our snake game screen and here let's pass these state. So first thing this score value we will take from the state. So we will take the snake size and we will minus the 1 because initially we will set the snake size to 1 because of that head. So every time that snake size will increase, so we will keep the score with that value. So let's scroll. So in this draw game board function, let's pass these grid width and height from the state. So next thing, let's draw our food. So again, after this function, let's create one more private function. So in this function, we will provide these three things. So here we need to use the draw image function because for the food, we will draw that apple image. So here let's use this draw image function. And here first we need to specify the image we will pass from the parameter. And next we need to specify this destination offset. And last, this destination size. For this destination size, we will use this int size. That image width and height will be of same size. So let's use this cell size as both values. And for this offset, so again let's use this int offset. So for these two values, we will take the coordinate x value and then we will multiply to the cell size. So here suppose we need to draw the image in the fifth cell. So it means the x value will be 5 and the cell size is 10. So it will give the x offset to 50. So in the same way, let's use this value to here also. So let's scroll up and after this draw game board, here let's use this draw food. So this cell size, we will take this value and let's convert it to integer value. And these coordinates we will take from the state. And for this food image, here let's create one value. So in this image bitmap, we have this function image resource. So we need to specify the ID. So let's use this r dot drawable because we pasted that image in this drawable package. So here we are saying this resource dot drawable dot image apple. So let's use this food image here. Now we can run our app and see this. So here we need to specify this state. So let's use this, all these default values. So we can see our apple has been drawn on the game board. Next we will draw our snake. So again let's create one more function with the name draw snake. So to draw this snake, we will take the list of this snake, and for each index we will draw the circle. But for the head we will take the draw image function. So here we will say if index value is 0, it means we need to draw the image, else we will draw the circle. So for the image we can copy this draw image, and here we will use the snake head image, and these values we need to provide the integer values. So what we will do, so here let's convert those cell size value to integer, and for the else block we will draw the circle. So we need to provide the radius. So for radius let's calculate the value here. So for radius, first we will check if that index is last index. It means we are checking this last index because for the tail we need to draw the circle relatively small than the other circles. So here we are dividing this cell size from 2.5, and for the else case, rest of the in middle circle we will divide this value to 2. So let's use this radius here, and these offsets we will give similar to this, only here we need to use this cell size, again cell size, but we also need to add the radius because we need to specify the center. Here we are specifying the top left offsets, so for the center we need to add the radius value also in these offsets. So let's scroll up, and after this draw food, let's use this draw snake. So this snake coordinates we will give from the state. Next we need to give the snake head image. So again take these images from the drawable, but here we will take the images with the help of when condition according to the direction. So here we have used this when block. So here let's press Alt Enter and add remaining branches. For these four direction we will use different images. Now we can use this image in our draw snake function. So let's run our app and see this. So here we have our snake. We are not seeing those body and that tail because we have just provided this single value in this list. But when we will play the game, then we can see those values. Next thing, we will create the view model where we will manage our state and we will write the game logic also in that. So here let's create one file with the name snake game view model. and let's extend this with view model. So this Android should know that this is our view model. So this view model is a part of Android architecture component that helps manage and persist UI related data across configuration changes like screen rotation, changing to light or dark mode. Hence, we will use this view model for our state and events. And for keeping those states, we will use state flow. So here I have created these two values. So this value I will use for reading and writing in this class, and this state value we will use only for reading. So in this way, this state value cannot be changed outside of the view model. And for these state, we are using this state flow. This state flow comes from this Kotlin coroutine API. Next thing, let's create a function where we will manage all our events. All the users action, we can say those are events. So again, let's create a new class with the name snake game event. It will be of type sealed class, and here we will use these data object. One of the user action will be start game, and another can be pause game, and one of the reset game. One action will be update direction. So here we will use this data class because we also need to keep some values in this event. So these four will be our actions. Let's go back to our view model and here create a new function with the name on event. Here we will pass this event and we will use the when. So here let's press Alt Enter, add remaining branches. And these two events, pause and reset game, will be very simple. In this pause game, we will just update our state. We update the state with this update function. So here we will get that whole data class and we will use this copy function. We will take the copy of that whole data class and we will just update our game state value to paused. And in the reset game, we will just pass our state value to the default state values. So whatever we use the default values, it will be set whenever user will click on this reset game. So next thing, we need to write the logic of the game whenever there is a start game event. So for that, here let's create one private function with the name update game. So in this function, we will pass our whole state class and we will return the updated state class. So first thing, we will check if the game is over, then we will just return from this function. So here let's use this if block and here we will say is game over, then we will return from this function with this current game as the state. And next, let's create some values. So whatever will be the first coordinates from this snake list, that will be our head. And these x-axis, y-axis, grid axis, we will take from the state. Next thing, we will update the movement of the snake. So let's just use the comment. So here we will calculate the new head. So let's use this new head variable and we will use this when block current game dot direction. So we will calculate the new head according to the direction. So here again let's press Alt Enter and add remaining branches. So when our snake is going upward, it means that x coordinates are not affecting, because x coordinates are on the horizontal axis. So we will just take the x coordinates from this head value. Whatever will be the x coordinate, that will be same. And for this y coordinates, we will subtract the 1 value, because that snake is going upward. It means that y coordinates are subtracting. So here we will take the y coordinate from the head and then we will subtract the value 1. So in the same way, let's copy these coordinates and paste this for the down value. And for the down value, again this x-axis will not be affected, and here we will just add the 1 value for this down direction. And also let's use this without these parentheses. And for these left and right, these y coordinates will be same, and these x coordinates in the left will be -1, and for the right will be +1. So this is how our new head will be calculated. Next thing, we need to check if the snake has collides with itself or goes out of the bounds. So again let's use this comment. So here we will use this if condition. We will say if current game dot snake dot contains. So if that snake list has contained this new head value, it means that it has collided with itself. And let's use these or, and here for the out of bound, let's create a private function where we will check this out of bound. So for the bounds, we will check if the x coordinates is in between these values. So here again we are checking from the 1, because in the 0 there is our board border, and here again we are subtracting the 1 value from this x-axis grid size. And in the same way we are checking for the y coordinate. Here after this, let's use this. So I have negate this is within bound value, because we need the opposite value. And for the coordinates, we have used this new head. So here, if that snake collides or goes out of the bound, then we will return our states with the game over. Next thing, we need to check if the snake eats the food. So again, let's put our comment. So here I have created this new snake value with this new head and this current snake list. So here we are checking if that new head coordinates matches with this food coordinates. It means that snake has reached to that particular cell. So here we will say snake game state dot generate random food coordinate. So now we will generate the new food coordinates, and in the else block we will just return the current food coordinates. And last thing, we will update the snake length. So here we are checking if that snake has eat that food, then we will use this new snake value. Otherwise, if that snake has not eaten that, then we will remove one element from the last. Here we are passing this new snake. For this new food, if the new head is equal to the current food, then we will generate the new food coordinates. Otherwise, we will use the current food. So we will use this update game function in this start game. First thing, we need to update our state to started. So here let's say started, and next we will use the view model scope to launch. So this view model scopes comes with this view model. So here this view model scope will give us this coroutine scope which will be tied to this view model. It means it will be cancelled when this view model will be cleared. So here in this view model, we will use this while block, and here we will check the game state. So here if our game state is started, then it will loop over this code. So here we will just put a delay of 100 millisecond, and then we will update our state value with our update game function. And let's also use these milliseconds differently. So here we are using this snake length as the when block, and if that snake length is in the 1 to 5 range, it means that game is in the initial stage. So that snake should move little bit slower. So here we will put the delay to 120 millisecond. And if the snake size is in this 6 to 10 range, then we will just increase the speed. And for the else block, we are using this 100 milliseconds. So here let's use that delays milli. Now next thing, let's attach this function to our screen. So for that, here in our game screen, let's scroll up, and here let's use that. So these two things we will pass in our main activity. So here, first thing, let's initialize our view model. So this function is coming from that view model compose dependency we pasted in that Gradle build. And let's also press Ctrl Alt O to optimize these imports. And after this, let's also collect those state values. Here we have this function collect as state with lifecycle. So this function will help us in collecting those state with the lifecycle aware manner. And we can also see this function is coming from that compose lifecycle. So for these two things, we pasted those two dependencies. Here we can see these two. So let's minimize these imports and pass these two values. Now let's run our app and see our app is working or not. So we can see our app is working, but if we press this start button, nothing will happen because we have not attach that event to this button. So we will do this next. So here we have these two buttons. So first on this replay button, we will attach our reset game event. And also we will use the different text with the help of if block. If that game is over, then this button should show replay, and if that game is in the paused state, then it should show this new game. And we will also enable this button when either we will be in the paused state or our game has been over. And if the game is in the started or in the idle state, then this button should be disabled. And for this second button, we will give the text with the help of when block. So we are checking here if the game is in the idle state. So this button should show start as the text, and if the game is in the started state, it means someone is playing, then it should show pause. And if that game is in the paused position, then it should show resume. So in the same way, we will attach the on-click event as per the button text. So here, if our game is in the idle state or in the paused state, then we will pass that start game event. And if the game is in the started state, then we will pass that pause event. And we will only enable this button when our game state is not over. Now we can run our app. So here we can see our game is in the idle state. That's why that first button is disabled. Now let's press this start button, and now we can see our button text has been updated, and we can also see that snake has goes out of the bound. It means that game has been over. So it is showing that replay button. So again, let's play that game. And let's also change that replay text to reset because that is quite confusing. It will just reset the game, not replay. Now we can start the new game. But we can see when our game has been over, some text should also be visible, so user should know that game has been over. So for that, what we will do, so here we will use the box layout as the parent layout. And again in this we will use the modifier.fillMax size. And here we will use the content alignment to center. So whatever will be the content of this box, so it will be aligned to the center. So what will be the content? First content will be this column layout. So let's minimize this from here and put it inside this box layout. So one child will be this column layout and another one we will use for that text. For that game over text, we will use the animated visibility because we need to animate the visibility of that text according to the condition. So here we have this animated visibility. We need to specify that when will the content of this animated visibility will be visible. So here we will say state dot is game over. If that value is true, it means we need to show this content. So here we will simply use text. So now we can run our app and see this. So let's start the game. Now we can see our game over text has been showed, and when we press this reset, that will be disappeared. So this animated visibility is working perfectly fine. Next thing we can see, when we press somewhere in this board, it is not changing the direction. So next thing we will give this functionality. For that, let's maximize this column, and here we have this canvas. So on this canvas we will use pointer input modifier. So here we need to specify the key to this pointer input. So we will use the state dot game state. So in this pointer input we have a function called detect tab gesture. So why we are using this detect tab gestures? We can also use clickable. The reason of using this detect tab gesture is this will also give us the offsets. So we will use those offsets to detect where the user has tapped on this canvas. So first thing, let's put a if block. So here we have used if that game state is other than started, then we don't need to perform any of this code. Then we will just return from this modifier. So in this detect tab gesture, we will get the offsets, and here we will pass these offsets to our event. And for that canvas width, we will use the size. So here we will get the size of this pointer input region, and since we are using this pointer input on this canvas, so the pointer input region size will be same of that canvas size. So we will take the width from this size, and this event we will handle in the view model. So here we have this event. For the update of the direction, let's create one more function with the name update direction, and we will use those two values from the event. And here let's press Alt Enter and create function. This needs to be canvas width. So here first thing, let's use that if block. So here we will say state dot value dot is game over, and we will negate this value. It means if that game is not over, then we will only update the direction. So here again, let's first calculate the cell size and tap X and tap Y coordinates. So again, we are calculating in the similar manner the cell size, and for the tap X and Y value, we are taking from that offset which will become through this event. And let's also take the head. So here we will update our state, the direction value. So here let's use again when block, and for the direction change, if the snake is going right or left, then it can only move upward or downward. For the right and left, the logic will be same, so we can put these two things in the same, and in the same way for up and down. So if the snake is currently going upward or downward, then we need to check the tap of x-axis, because if the user has tapped right side of that snake head, then user wants to change the direction to the right side. If the user has tapped the less value than the head of x coordinate, then user wants to go to the left direction. So here we will check the if condition. If that tap x value is less than x coordinates of head, then user wants to go to the left direction. So in the same way, we will check the tap of y for the right and left direction. So this is how we will update these directions. So let's run our app and see this. So let's play this game. So we can see our game is working perfectly fine. But one last thing we also need to do is those sound effects, let's also add. Let's minimize this and let's go to our game screen. And first thing, we will get those sound values from the resource package. So here we will use this remember block. So this remember block will keep remember the value across the recomposition. We have this media player, android.media, and here we have this create function, and we need to pass the context and the resource ID. For the context, here let's create. So this is how we get the context. So let's pass this context here and the resource ID. So this is the one we pasted in that raw package, this one. So let's put this in the single line and duplicate this value. So now how we will play these sounds, because in our screen there is no button to play these sounds. So what we will do, we will use the launched effect. So when you use launched effect, you are saying, hey Compose, I want to do something extra here, but I don't want it to affect the recomposition of my UI. So code here will run independently of UI recomposition. Let's use the key to snake size. So the code in this launch effect will be run on the initial composition, and when the composable is recomposed, Compose checks these keys to determine if an effect needs to be re-executed, If the key changes, the effect is considered new and its code block will run again. So here we will put the if block. So on the initial recomposition, it should not play that sound. So initially our snake length will be 1. So here we will say if our snake length is not equal to 1, it means it is of 2, 3 or something else. So then we will only play that food sound. It means a snake has eaten that food. So let's use that food sound media player and let's use this question mark. So this food sound can also be null. So that's why we are safely using this start function. So with this start function, it will play this sound. So in the same way, let's use this launched effect for game over sound. For the game over sound, we will only play when this state dot is game over will be changed. And again, we need to put this in the if block because initially our is game over value will be false and we don't want to play this sound on the initial recomposition. So we will say if that state dot is game over will become true, then only play this game over sound. Now let's run it again. Now let's play the game again with the full volume. Here we can see our game is working perfectly good and our sound effects are also playing. That's all for this video. If you have found this video helpful, then hit that like button. And if you have any question, you can ask in the comment section and do subscribe for such amazing videos. Thanks for watching.